This is Mrs. Sturgeon, and we are going to talk about how to write a compound inequality given a graph. So let's go ahead and jump right in. We're looking at the first graph right over here under example 2. So notice on the graph, I have two open circles. One of them is at -2, one of them is at +5. So I will be using both of those numbers as I'm writing my compound inequality. The other thing I notice is that based on the fact that the shading occurs between the two dots, that means that this is called an AND statement. I'm going to write that down, an AND statement. Okay, so because of the fact that this is an AND statement, there's actually a couple of different ways that we can write this inequality. I'm going to go ahead and show you both ways, and then we'll probably stick with one way after I show you both of these. So first and foremost, the shading, let's look at where the shading is with respect to -2. So -2 is over here, great. Now the shading occurs to the right of -2. That means those are numbers that are greater than -2. So one way I could write this is x is greater than -2, and let's go ahead and switch over to the +5 dot. The +5 dot has shading to the left of it. That means those are numbers that are less than +5. So I would say x is less than 5. That's one way that I could write this. Another way that you might actually see pretty frequently is like this. You kind of put it together into one single statement. So it goes -2 is less than x, which is less than +5. This is the more common way that you'll see compound inequalities written. So that's the way that I will stick to for the next example. Okay, so for something like this, we've got -4 and we've got +2. So what I like to do is put -4 here, put x in the middle, and then put +2 and fill in the blanks with my actual signs after I actually put the layout and the setup on the page. So -4, I have shading to the right of -4. Those are all numbers that are greater than or equal to, because this is a closed circle, remember, -4. So this is the way my arrow needs to be facing, okay, because x has to be greater than or equal to -4. And remember, in inequalities, I like to think of it this way. X, if it's facing the x, that means it's greater than or equal to whatever the number actually is. So it's eating the x, that means x is greater than or equal to -4. Okay, so now when it comes to +2, in this case, we have shading to the left of +2. That means that I need my little inequality symbol to face this way, because again, the numbers are less than 2, so it should say x is less than 2. For this next set of examples, let's talk about what happens when the arrows are facing the opposite directions. That means there is an OR statement. So for OR statements, we don't tend to write them together as one single statement. We actually write the word OR. So that's how I'm going to go ahead and approach this. So for the first inequality, I have -1 open circle, and then the shading is to the left of it. That means x is less than -1. Because I know this is an OR statement, I'm going to write the word OR. Now I'm going to jump over to the 3. Now the shading is to the right of the 3, so 4, 5, 6, all those numbers are bigger than 3. And it's an open circle, so it should be x is greater than +3. And that's my answer. Okay, last example. So in this case, we have closed circles on both -4 and 6. So let's go ahead and start with this left inequality. So since it's a closed circle, that means x has to be less than or equal to 4. So again, line goes underneath the or equal to when you have a closed circle. Okay, and it should be -4. Whoops. Okay, so go ahead. X is less than or equal to -4. So all those numbers shaded to the left of -4 are numbers less than or equal to -4. Now, we know it's an OR statement. We're facing opposite directions, so I'll write the word OR. Then, we've got numbers that are greater than or equal to 6. 8, 10, all those numbers are greater than or equal to 6. It's or equal to, again, because of the closed circle, and that's how you write compound inequalities.